Welcome to the session. Greeting of the day. In today's class, we are going to talk about a dye-penetrant inspection method. Out of these non-destructive methods of all visual, liquid, magnetic particle, current, radiographic, ultrasonic, acoustic emission, infrared thermography methods, in this class we will talk about this liquid penetrant testing, this one. In previous classes we have seen about inspection and quality controls and how to manage in the stage by stage a continuous monitoring system is required, and some varieties of non-destructive testing methods. In continuous with that, here what we are going to see today in this method, it is a surface inspection method. Maybe other methods are there which is helpful, useful for inspecting the subsurface methods, like when the crack is inside the thickness. Out of 13 thickness, if the crack is in the middle of 15th mm or 27th mm or 17th mm, we can't able to see through our naked eye. At those conditions, we have adopted other methods like radiography testing methods and maybe ultrasonic inspection methods. So these two belongs to volumetric and planar inspection, such as we can tell as a subsurface. Now, out of this, we can able to tell now when the defect is in the surfaces. Even this is also possible. Radiographic test also possible to detect in surface inspection. But this and all, when comparatively, this needs a film. The inspection itself done through film processing methods. So the source will fall on the film, then film have to be developed, and then we can able to inspect or interrupt. But here in this remaining other methods, visually we are going to judge like visual inspection. Directly we have used some magnifiers and lenses. And our topic is today is the liquid penetrant test. It means nothing we usually call it as PT, penetrant test inspection methods, PT, penetrant test. So here we are using some penetrant methods, contrast color penetrance and developing process. So again we are going to see it is enhance the visibility by giving some contrast color. Not only visual inspections without any colors, we have just seen. And that is this first one, visual inspection. But the human eyes are sensitive, not sensitive, less than 0.08 mm. Above 0.08 or 0.9 or 1 mm, it is very sensitive. We can able to see by our naked eye. But when it is less than that, it is not possible to detect, or not that much. You have to stress our eyes. Then only it is possible. So therefore, so we are preferring some other methods like liquid penetrant test. So on here I am giving some classifications such as surface crack detection and subsurface crack detections. On the subsurface we have some other ultrasonic and radiography. In the surface crack we have visual inspection, liquid penetrant, magnetic particle, eddy current methods. Out of this floor, we are seeing today about a liquid penetrant test, PT. Each technique has advantages and disadvantages with respect to their technical capability, and because this technical capabilities, this PT is only possible for surface inspection. This technical capabilities, this is suitable for both the surface, for radiography, both surface and subsurface. So likewise, we have to choose the NDT technique based upon their consideration, availability, and the complexity we are going to inspect. So as of now, we will enter into penetrant test. So in this, out of all this process of 8 visual, liquid, magnetic, eddy current, radiographic, ultrasonic, acoustic, and infrared thermography, we are going to see about this one. So this liquid penetrant test now. It's also called as this liquid penetrant test, also called as a dye penetrant test, DPI, or liquid penetrant inspection, LPI. I have told you here PT, penetrant test. So I am telling us inspection, all are very similar. penetrant test, otherwise as a PT. That's what we have given as a heading. It is widely applied and low-cost inspection method used to locate surface breaking defects in all non-porous materials. Because why it is a non-porous material? Let us assume a porous material like a sponge, or when the material, a penetrant, we are going to use some liquid penetrants which is want to pour, and it should go inside and stop there. And then when your powder liquid is applied over there, powder developer is applied over there, liquid will be absorbed by the developer and some color contrast will be visible there. When we are using a porous material, the liquid will keep on going downwards due to its porousness. And therefore this capillary actions and the absorbing of the developer, those liquids towards the upward direction, this scenario will not happen. Then this process will not be helpful. Therefore this PT, penetrant testing operations, is not useful in porous material. Therefore I have mentioned as useful only in the non-porous material like metals, non-porous material like plastics, non-porous material like ceramics, or any other material which is non-porous in conditions. So those things we can able to utilize. So our weldings are not happen here. So welding, casting, forging, or extrusions, any other mechanical processes, extrusions, all are happened in the all metals and ceramics. So these are all we need to do the inspection. It is mandatory. Welding are too much cracks, visible cracks we have to identify. How they have done welding process, how they have did the grinding operations, how they lathing, all these things we have to subject to inspection to find the discontinuity, it means the defect. For those finding discontinuity, when it is less than 0.08, our eyesight is not suitable. Then we depend on this penetrant testing methods. It's a contrast colors. This technique is normally used to detect the surface defects like the castings, forgings, weldings, such as hairline cracks and micro cracks. Which is hairline cracks are not visually, if it is less than 0.08, it is not visible to see by our naked eye. So we are independent. Hairline dependent on some other form. So that form is penetrant testing using a contrast colors. Hairline cracks, surface porosities or leaks in the new products, maybe liquid leaks may be there on a frame, so that needs to be verified. So fatigue cracks on in-service components. The fabricated component may not have, but the same fabricated component, when it is subjected to load, it may be a leak, it may be a fatigue crack, may be initiated during service actions. So that time also we should check where it is. It's like an example, we are in our bikes or cycles, we are going for punctures. They dip into some waters and the bubbles may come. That is, we are doing some additional exercises to find those porous holes. So similar to that, we are using some contrast colors here to identify. So say before 1900s, we have using some other platforms to inspect. So such other platforms are nothing but a very early surface inspection technique involved in rubbing off a carbon black on a glass portlet, whereby the carbon black would settle in surface cracks, rendering them visible. So on the surfaces, this penetrant test is only for surface. It means we are going to do inspection on here. This is surface, right? And we can check this is subsurface. So therefore, this when we are putting the carbon blocks as scraps on powders in the format of outside at the top surface on the material, when the crack is available here, it falls there. So it is visible. So therefore, it is visible. On object, which is white in color, Let us assume this surface is in white in color. Now it is very difficult to see the cracks over there on the white plates, plain surfaces. It's something it is difficult to see the crack which is a bright white color. So we need some contrast there on the surface to check whether it is okay or to identify. Therefore, what we are doing, if I rub any black material, rub is just I'm taking a carbon block and rubbing there on the surface. What happens on the crack? This rubbing mixtures will fill those gaps. So this idea they have used in 1900s. And black color will fix onto that. And after cleaning, just after cleaning, so on the surface while cleaning, wherever the crack is not there, what I am doing here, you see, I have taken a sample and I am rubbing this maybe any other color over there. Now I am rubbing here, just like a chalk piece I am rubbing here. What happens? Here some small crack is available. It is assumed here some crack is available, a small crack is available. Therefore, this yellow color chalk piece what I am using, here it is yellow color on the board, but where they were using the carbon black. So what happens, they are inserting here, when they are rubbing, this powder is falling over here also. So it is falling over here also. Now, after that, I am wiping out, cleaning. So when I am doing the cleaning operation, here, it is the carbon black which I have wiped out, it is went out. But the carbon black which is went inside the crack is not possible to remove because it is inside. We are able to remove only the surfaces. We are removing only the surfaces. But the carbon block which is went inside the crack, it is below the surface. We are possible to clean only the surface. When we are doing the surfaces only is clean, not the bottom. Therefore, it is staying there. But in what color? This is in white color. So this is in white color. So this is in white. This is in white color, and this is in some other in the black color. So this is in the black color. So out of contrast colors, we can able to identify this. This is what they have did. But now recently we are doing some Penetrant color liquids. Earlier they use the carbon blocks. So after cleaning, it is easily visualized the crack line by that black nature on the white object. So black nature on the white object is visible because it is contrast. It is done in the 1900s. Now later, they are used other methods also. So like oil and whitening methods. In this method, heavy oil commonly available in the railway workshops was diluted with the kerosene. So we are adding some kerosene on the oils and large tanks so that locomotive parts such as wheels could be submerged. I am dipping those parts which is I want to inspect into the tanks which is filled by oil in combination with the kerosene. So first we are doing some pre-cleaning and dipping the hot bath of oil. We are dipping inside. After removal, after taking out the compound, careful cleaning the surface was then coated with a fine suspensions of chalk on the alcohol. So we are now, after taking out, the kerosene have to evaporate. So that's the nature of it. But oils, what it is, wherever the crack is there, oil will be inside the crack. So air bubbles and oils are went into the crack, but it is not coming outside. Only the kerosene is going to evaporate. Oils which are dropping down on the tank itself. We have taken out the product. And we have kept here like this, you see. They have taken out the product and keeping, and it is kerosene free. It is evaporated. But the oil on the surfaces falls down. But the oil which is inside the crack on the hole, it is inside. So it should come out. How? So we have to vibrate. So that the white surfaces layer was formed once the alcohol and the evaporated. So on the surfaces, we are putting some white color, chalk colors we are just pasting. After alcohol is evaporated, a complete white color product will be looks in a complete white color because we have coated the white color on the surfaces. Then we have dried out. So coating with the fine suspensions of chalk and alcohol is taking place. So that it is over there. The object was then vibrated. So the oil want to come out and interact with this chalk powder. So vibrated by being stuck with the hammer. Some hitting some actions or some vibrating, shaking we are doing. Causing a residual oil. Residual is nothing but a stored oil on the crack. Residual oil in any surface cracks to seep out and stain with a white coating. So we are already did here a white coating. This is now oil is absorbing or oil is absorbed by the chalk powders. It's on the surfaces. Last it's then carefully examined with a magnifying glasses if required. Glasses are if required you can magnify. So this is one of the steps they have followed, kerosene oil. So what they have did here, they have a sample and then they have in the oil tank, in the oil tank they have filled with it is consists of kerosene and oil. Kerosene oil they have dipped and they have coated. Now this kerosene is everywhere it is filled. So now it is taken out of the sample. So it is now it is taken out. So it is taken out. Even it is taken out, some of the are there. So when after it is taken out, so kerosene filled is there. Now I am doing some chalk color pasting over there. So chalk has been kept over there. Now after I want to drying operation we have to take. When it is a drying operation this takes place, the kerosene is evaporated. Corrosion is evaporated. If it is kerosene is evaporated, only chalk powder is available on the sample. Now already oil is also available. So now what happens when the oil comes out, when the vibration takes place? Takes place, the oil which is set inside is absorbed here. Somewhere it is absorbed there. Whenever the crack is sometimes available. So crack may be available here. So crack may be available here, may be available here, may be available. Due to shaking actions of vibrating action, the oil comes out and attached to the, and it is attaching to the white chalk powder. So we can able to find this location. So it is coming out, oil is coming out. So it is easy to identify. So later in 1940s, a visible dye penetrant. Now what we are using nowadays also. So more effective penetranting oil containing highly visible dyes were then developed to enhance the flaw detection capability. Even though the oil is colorless. So instead of that we are using some visible dyes to maybe color various red, green colors, red colors we are using to highly contrast visibility. So this method is known as a visible color contrast dye penetrant inspection. So there is nothing but a visible dye penetrant method. So still used quite extensively today's also. Some 1990s only we have invented these processes, dye penetrant testing methods. So in 1942 later, some fluorescent they are adding. So for the green color, bright colors, fluorescent it is blinking. So fluorescent dye were added to the liquid penetrant. These dyes would then fluorescence when exposed to ultraviolet light, sometimes referred to as black light, rendering indications from cracks and other surfaces flaws more readily visible to the inspectors. So it is somewhat more visibility increasing through the contrast fluorescent platforms. Like this fluorescent color we are using as a penetrator. Many of these early developments were carried out by Magnaflux in Chicago, Illinois, USA, in association with the Switzer brothers from the Cleveland, USA. So these are some of the basic initial inventors of this fluorescent dye penetrant system. Started from 1942. Now we can. Dye penetrant inspection is based upon a capillary action. So it is one of the main important method we have to understand. Where a low surface tension fluid penetrates into clean and dry surface, breaking discontinuities. The capillary action is also known as capillarity or capillary motion, otherwise a capillary effect, otherwise called as wicking processes. So the basic principle of dye penetrant inspection is based upon this capillary action method. This capillary action takes place between the crack and the developer, between the surface and the crack. So that is why the liquid which we are pouring, penetrant which we are pouring on the surface is getting into the crack. At the same time, when the developer, the white color powder is applied, it is coming out of the crack. So this happens like absorbing. We could have seen when the water falls on the floor, we put some clothes over there to absorb those waters. So such things happens. It is the ability of a liquid. See, it means the capillary action. It is the ability of the liquid to flow in a narrow space. So it is a somewhat a sharp corner. I am calling this as a narrow. So likewise, a narrow space without the assistance of pressure. We are not pushing, but it is getting into the pipes or any narrow hole, that is through its surface tensions is moving in. So, or even in the opposition or to external force like gravity, even with the opposition of gravity, it wanted to move inside. See, here in the small narrow pipes are dipping into the pipe. So this is the various tubes are there. So one tube, here one tube, here one tube. We are supplying the tube here with various diameters. This is a small diameter, a medium, larger, a larger. So out of these all pipes, the water when we are dipping in, the water is due to this capillary action getting inside it. Even the gravity is pushing its downward direction. The water is moving in the upward direction by the capillary action, which pushes the water over the small tube with opposing of this gravity too. So that is how it happens. This method we are using for penetrant testing because the crack is available here and we are going to pour the liquid here and the surfaces. It is wanted to penetrate here and it should fill. And when we are applying the developers, here, it should come upward and fill here. So that is happens. The capillary action occurs because, and the definition we are defining here, capillary action occurs because of intermolecular force between the liquid and the surrounding solid surface. So let us assume a plate here, and I have a lap joint also here. I am having some lap joint here. So during this soldering operation, we could have seen this when we are keeping the filler wire, that lid filler wire, tin filler wire, when we are keeping here at this point, and we have melted through gun. What happens? This filler material in the soldering operation, it moves inside this gap. See, there's when we are keeping a lap joint, there's a gap between these two. But the soldering has to be taken place in the gap. This lap joint to be done here. This gap needs the filler wire to attach these two sheets. There the capillary action takes place. So we are keeping the soldering wire here, and due to this capillary action, between the soldering liquid metal of lid we are using liquid metal, and then the surrounding solid surface. Solid surface is 1 and 2. These two solid surfaces. This liquid metal will want to go in between these two plates, and the soldering process has to be take place. So this process is taken place by the capillary action with respect to intermolecular force between the liquid what we have melted by the soldering gun and the surrounding solid surfaces of this sheet. So with respect to this capillary action takes place. We can take some other example of a tree which takes the water from the ground, and our blood pressure which from the body to our leg, it is moving up and down, all with respect to this capillary action forces. If the diameter of the tube is sufficiently very small, then a combination of a surface tension and the combination of The combination of surface tension and the combination of adhesive force between the liquid and the container wall act to push the liquid inside the gap of the two material. So here we have the surface tension of the sheets, this metal tube, and then the adhesive force where it absorbs and fixes over the surfaces. This two act forces belongs to intermolecular forces. So we have some tension we have. At the same time, we have the adhesive gripping forces which makes the liquid to flow over the container walls of the surfaces. So, for example, I am telling it is the same. The water movement in the plant against the force of gravity, and the blood flow is taking place inside the human body. So, these are some of the examples of our actions, capillary actions. A person with a perfect vision cannot be able to see this defects which is lower than that of 0.08 mm. So we have seen a person with perfect vision cannot solve the features smaller than that of the 0.08. It improves the detachability of a flaw due to the high level of contrast between the indications and the background, which helps to make the indications more easily seen, such as red indications. So we are using some contrast color here. See, we have a surface and the crack at the center. We use the penetrant which went inside by the capillary action, and the color indicates the contrast visibility. So on the white background for the visible penetrant, or the penetrant that glows under the ultraviolet light for the fluorescent penetrant. So some of the easily understandable contrast color, maybe specifically we are using a red penetrant. Liquid penetrant testing is one of the most widely used NDT methods, a visual with penetrant. After penetrant applying, after 12, we subject it to visual inspection. Its popularity can be attributed in two main factors. So that are, it is relatively easy to use, maybe less training we need. In practice, we have to spray a penetrant first to clean the surfaces, to remove the gas, oil, grease items which are all available in the surfaces in the industrial circumstance, and then we have to apply the penetrant and then wait for a while, then clean the penetrant. Obviously the penetrant is vented to the crack, and then we apply the developer, some powder, white powder, and penetrant absorbed by the powder, and it is differently colors is looking. So we can able to easily understand. So therefore it is relatively easy to use, some less trainings, and it is also it has some flexibility. Materials that are commonly inspected using this method include metals. First it is metal. We have metals, glasses, many ceramic materials, rubbers and plastics also, or almost all materials which are used in the industrial circumstances is possible to inspect by visual penetrant inspection methods. It can be used to inspect almost any materials provided that its surface is not extremely porous. So this topic we have already discussed. Some porous sponge type material cannot be went through for penetrant testing, because when the liquidized penetrant liquid is poured, through porousness it will keep on going inside. It finds the root and keep on moved. Some root to be stopped. A root means we can say it is a crack, is a root which is stopped here. Now let us consider a porous material. So here may be some holes, here maybe, and here maybe it keep on going somewhere. A porous material. So on that, when the metal liquid is coming here, when the liquid is coming here, you can see it is keep on moving somewhere. So it is not suggested to use the rough or porous material for penetrant inspection. Right? By penetrant inspection, porous material cannot be inspected. The surface cracks or the flaws, see. However, liquid penetrant testing can only be used to inspect for flaws that break the surface of the sample, such as maybe surface cracks, maybe a porosity, which is a single porosity. It means at the surface only, it is not extended to the bottom. So such porosities, lamps or seams, lack of fusions can be detected by using the penetrant testing method. So we have seen some about the introduction part of the penetrant inspection. Here we have various test procedures how we are going to do some surface preparation, penetrant application, penetrant dwell time, excess penetration removal, developer applications, indications, inspection and post cleaning. So there are various steps involved in such a way that moves. So it is going. So we have to see these various steps, what are they involved. The remaining part of the subjects we see in the next session. Thank you.